This is WFNP 88.7 Rosendale. Welcome to Curiosities of the Cosmos. I'm your host, Allyson Sheneman. Today I've brought on Stoker Stoker to talk about observational astronomy. Welcome to Curiosities of the Cosmos with Allyson Sheneman. My guest today is Stoker Stoker. Stoker is a senior astronomy major at SUNY New Paltz. They are a planetarium show presenter, a researcher, and an astronomy teaching assistant whose main interests are in astronomy outreach and education. Stoker, thank you for coming on the show today.
Absolutely. I'm super excited to be here.
For our listeners, Stoker and I are both studying astronomy at the same undergraduate university. We've taken many classes together. We also both work at the planetarium and have that shared interest in public science communication that probably brings us both here today. So I'm very excited to have them on the show. So thank you again for making the time to come in.
Really of course.
Awesome. So I'd love to start the episode off by talking a little bit about that shared passion for science communication. I know currently you're looking into maybe pursuing a career in science communication. Can you talk a little bit more about like what that looks like and what draws you to that as a career?
Yeah, absolutely. So I guess I've always been absolutely fascinated by space and astronomy, everything that's going on up there in the sky.
Yeah.
I wanted to know about, I wanted to learn about, and nothing makes me happier than being able to share my knowledge with other people, especially because I think a lot of people are really intimidated by astronomy.
Totally.
They think, oh, it's super hard. And whenever I tell people I'm studying astronomy, they're like, oh my God, you must be so smart. And it's like, I mean, a little bit, but not,
Yeah.
I'm not like a genius or anything.
Right.
So I have really just wanted to be able to share that kind of stuff. And in terms of like the kind of career I can get in science communication, I think I'm doing really great so far working in the planetarium at SUNY New Paltz. That's a great way to get into it. I'm looking for other jobs in other planetariums. I'm also looking at jobs at various science museums. And of course, there are always like teaching opportunities, but I tend to lean more to liking something that's a little bit more informal, if that makes sense.
Yeah, totally.
So I'm really excited to be able to try to just share my knowledge with people and get people excited about astronomy.
Yeah, I think I totally relate to that feeling that like it is something that I think a lot of people view as so intimidating that they don't even bother. Especially if you say like astrophysics instead of astronomy, it like always scares people.
Yeah, I do know though, when I want to sound smarter to people, I say I'm studying astrophysics,
Right.
But if I want to be more relatable, I say astronomy.
Exactly. And so I think that sometimes that like intimidation scares people so much that they just become uninterested. And I think because of that, people also are kind of out of touch with the field a little. And so when I tell people that I'm studying astronomy, the first question I always get is like, what does that do? Like, what jobs does that get you? And I think people have a kind of narrow idea sometimes of especially in STEM, the like degree to job pipeline.
Yeah, I do know. I get so many people being like, oh, you're going to work for NASA.
Right.
And I was like, that's one of the options, but
Exactly.
Yeah.
Yeah. And so I think in astronomy, it's a lot of like, oh, well, if you're studying astronomy, you're going to NASA. And if you're studying, like computer science, you're doing this specific thing. Or if you're just studying biology, you're doing this specific thing. And I think something that I find is that it's not, like so many people study astronomy or study physics and then go off and do something completely unrelated because a lot of like just general STEM skills are so transferable.
Yeah, absolutely. Absolutely. I think, honestly, it's one of those things where if somebody's like looking at your resume and they say, oh, you have a degree in a STEM field, you're smart. Just like I was saying earlier, like, oh, you're so smart. You've got problem solving skills. You can figure things out. And that's something that a lot of people want, like in all fields. We want problem solvers.
Yeah. And I think especially for people who are interested in science communication, there's a lot of like being able to kind of public speak and like present things in a way that's understandable, to like synthesize information and kind of condense it into a way that people can understand. There's a lot of like presentation skills that I think also transfer over. Have you noticed any skills that you have from either doing stuff at the planetarium or at the observatory that you feel are going to translate really well into either a career in science communication or something else if you end up doing something completely different?
Actually, one concrete example I have that has actually happened to me is at my job in retail.
Yeah.
I'm a little bit higher up. I've gotten a couple promotions. I'm not like a full manager or anything. But my store manager did ask me during one of my reviews, she was like, do you do any teaching? Because you seem like you're really, really great at like mentoring people and communicating things effectively. Yeah. And I was like, not like formal teaching, but I do work in the planetarium. So I do like teach people things.
Totally.
So definitely there's a lot of transferable skills, and just being able to work with people and being able to talk to people in a way that they can understand, even if sometimes it takes a couple tries to get somebody to understand things. That's a super valuable skill.
Yeah, absolutely. And I think also the planetarium has so many different types of people that come through. I mean, we do shows for like elementary schoolers. We do private shows for like birthdays that people just kind of rent out the planetarium for. And then we have public shows where it could be anybody from young children through to professors that are working here in completely different fields. And so I think it's really also a great skill to have, to be able to make information understandable across that kind of like wide gap and spectrum.
Yeah, definitely. There's a lot of, like, for example, I've noticed that I think there's like this series of YouTube videos that are like science videos where they explain science concepts at like different levels, and you see how it progresses from each level. Yeah. And in my head, that's kind of like what we do, because like I've done shows for honestly ages that probably don't get a ton out of it. I've done shows for 4-year-olds, but yeah. I've also done shows for like, there was a private show I did for a family where most of them were a little bit older, and I've done private shows for like company like outings.
Right.
Yeah. So like they're all adults, so I can give them a little bit like of a higher, like intellect level, like with what I'm explaining.
Yeah, absolutely. I also found that beyond just the presentation itself, I mean, there's a lot of multitasking that goes into doing a planetarium show, from like having to like write the show itself and then be able to like follow a kind of like outline of what you're doing, staying on track with that, being able to talk in a way that's like inviting and engaging to people. You're also controlling everything that happens and not just doing computer stuff or working with, we have an old like star ball, and so there's a lot of like kind of older machinery that comes with that. And then on top of that, there's like laser pointers and you have to point things out. You're controlling all of the lights in the planetarium. There's so many different like aspects of the machinery there. But I've also found that in working with that machinery, specifically our old star ball, which for people who don't know is just kind of like, I don't know, it's like it's kind of as if it's the Earth, but there's light coming out of it, and that kind of projects the stars. I don't know if there's a better way to maybe
I mean, I just say
that.
It's basically a big sphere with holes poked in it where all the stars are, and a light inside that makes the stars project out.
Yeah, perfect. That's much better than what I did. And I feel like specifically in working with that one, because it's so like analog, if that makes any sense, it's like I feel like I have such a better grasp on the night sky and like the mechanics of how everything moves. And so going out and then observing with real telescopes, I feel like those skills really transferred over to that too, where I feel like now I have a much better sense of how the sky actually works and moves from my experience in the planetarium.
Yeah, absolutely. I love our old star ball. I know there have been rumors, the planetarium director say people keep trying to get him to replace it, and we're all like, absolutely not. You cannot replace the star ball. We love it.
Yeah.
I think it's really fantastic because I think it actually does a better job of showing the motions of the sky and the sun and the planets better than our like digital projector and the computer programs we have.
Yeah.
In fact, actually, really recently, I did a show for a geography class at SUNY New Paltz, and I almost entirely used the star ball for that, to show them just how things move in the sky, how the sky changes over the course of the day, over the course of the year, latitude, longitude, you know, stuff like that.
Yeah.
So I think it's really important to have something that kind of, I feel like computers are great, obviously,
Yeah.
but the like analog nature of the star ball makes it feel more like it's accurate to what's actually happening
Totally.
in the sky.
Yeah, and I think a lot of that too comes from like having to do all the setup when you're using the star ball. And so you don't just sign in and then put in the numbers and then it gives you that date and everything is already kind of set up for you. You have to like move the sun to set the date, and you have to like control where the like day or night is starting out for the show. Like you're controlling all of that stuff. You're controlling the seasons. You're controlling like your latitude, that kind of thing. And so I think having to kind of go step by step and input each of those things makes you more aware of what each of them does to change things. I brought this up on a different episode, but just the idea that like setting it to the North Pole means that everything kind of rotates around the top.
Mm-hmm.
And so there's not really this like rising and setting of the stars. And having it at the equator means that everything rises and sets. And I think actually being able to see the star ball move from the equator up to the top, immediately everything that had to do with how the stars change based on your latitude clicked for me.
Yeah.
And it really only took the first time of doing that where I was like, oh, okay, this all makes sense
Yeah,
now.
absolutely. Another thing that's really cool, it's a slightly more complicated concept, but the concept of precession, which
Yes.
is essentially the Earth's axis of rotation, kind of like a wobbling top. It draws out a circle through like the sky. It remains at the same angle, so it stays at the same 23.5 degrees tilt. But it points at different stars, and it's a very, very slow process. It'll take thousands of years, but eventually, like, the North Star does eventually change. And since it's such a long process, I found it really hard to understand when I initially learned it. But when I was in the planetarium and using the star ball, you can simulate precession, and that made it make so much more sense to me.
Yeah, absolutely. And I think it's so important because there are so many of those concepts where it's like latitude changing is probably something I could have just sat long enough with and figured out. But precession is one of those things that even if you sit with it for a while, it can still kind of not quite make sense.
Yeah, and honestly, even when I was like presenting stuff in the star ball with precession, it still took me a couple times to fully understand like what exactly the like effects of it are. And it's basically just that the stars shift in their places. So like you know how we consider like there are certain seasonal asterisms, which are basically like stars that we see at different times of the year. So we have like the summer triangle that we see during the summer months. Due to precession, for like half a cycle of precession, which would be like 11,000 years, we would see that more during the winter time.
Right.
So it's pretty much just shifting what time of year you see the stars.
Yeah. And I think there's something about that too that just really sets into perspective how long that is and also how short of a time humans have really been around. Because I think it's so fascinating to me that like when we think about like ancient civilizations and their views on the stars, they pretty much completely align seasonally with how we see the stars still today, because they really weren't that long ago compared to how long these things take to happen.
Yeah, exactly. The stars change very, very, very slowly.
Yeah.
I think the only like noticeable difference was the Great Pyramids of Egypt. They built those to align with their North Star at the time, which was the star Thuban in Draco, instead of our current North Star that we have, Polaris, which is in the constellation Ursa Minor, or the Little Dipper.
Yeah. That's awesome. And I think a part of it too is like sometimes people get scared about like they hear like, oh, this star is gonna supernova, or this star is gonna explode, this star is gonna this and this and the other thing, and like, oh my god, the stars move over time, and they get like scared almost of the fact that those things are gonna happen. And I think people forget that they're on such crazy timescales that a star supernovaing like soon is still a really long time away.
Yeah, absolutely. So it's really one of the things that I think a lot of people struggle to wrap their heads around with astronomy is that the timescales are so vastly different than the timescales we expect. Like for me, a long time is like 6 months.
Yeah.
The 6 months is a long time to me.
Yeah.
But in terms of astronomical time, 6 months, nothing.
Right.
That's
Totally.
nothing.
And I think that kind of segues us into our first segment on the show, which is, should we be more worried about? So through like years of doing public science communication, you get asked a lot of questions. And a lot of them are people who have learned about a concept often recently that they don't fully understand and aren't sure if they should be more scared about than they are. And so I've had people come up to me and be like, this thing is going to happen. Like, how come I don't see it on the news? Right. And so this is going to be a segment where we kind of decide whether or not a certain topic should be more worried about. We should maybe be talking about it on the news, or if it's something that maybe sounds scarier than it is. So, Stoker, should we be more worried about supernovae and black holes?
Short answer, no, not really. Long answer. So I have been studying supernovae, which we're going to talk about later, but supernovae are common in the terms of the universe. There's a lot of supernovae happening at all the time because the universe is huge and there's a lot of stars. But in reality, in terms of just our Milky Way galaxy, we can usually expect an average of maybe 1 to 2 supernovae per century. And that average is a little bit skewed because, you know, for example, if I said I run an average of 1 mile a day, that could mean I run a mile every single day, or that could mean once a week I go and I run 7 miles.
Right.
So they're not as common as people think they are, and the Milky Way galaxy itself is really huge. It's like 90,000 light years across. Pretty much the danger zone for a supernova explosion, for if it would really harm Earth, is as long as it's farther away than like 300 light years, we would get almost no effects.
Okay.
And another really good thing that makes us less worried about the potential of supernova going off basically in our lifetime is that around 20 million years ago, we have some record that there were some supernovae that went off kind of close-ish to us. We see some of the effects of it that came to Earth through the geological record. We see like certain isotopes of iron that indicate the presence of a somewhat nearby supernova. And because we had those supernovae happen, they kind of cleared out the space around us a little bit. We're in something that we like to call the local bubble, which is we have a lower density of material around us because these supernovae explosions that happened not very long ago astronomically,
Right.
but long ago for us people, they kind of cleared out some space. So there's not a lot of stuff super close to us that we think, actually we know there's really not much in our, like, the kill range of a supernova that would go off soon. A lot of people hear about the star Betelgeuse.
Yes.
There's been a lot of talk about that one. That one we're thinking it might go supernova pretty soon. It may have already gone supernova, or it may go supernova in 10,000 years.
Right.
But the thing is, Betelgeuse is 640 light years away from us. So even if it does go supernova, the only result that we'll see is a very pretty light show in the
Right.
sky. So I almost hope Betelgeuse goes off in my lifetime just because I want to be able to see it.
Yeah.
But there would be no adverse effects to Earth.
Right.
And then in terms of black holes, so most commonly black holes come from really, really massive stars that go supernova. And there are some wandering black holes, but they're kind of smaller, and honestly, they're not extremely common.
Mm-hmm.
So the likelihood of one just passing through our solar system is really, really low, and I'm not concerned about it.
Yeah.
And I think also people have the misconception, our professor and advisor, Dr. Amy Bartholomew, talks about this a lot.
Yes.
They have the impression that black holes just suck in everything around them, and that's not quite true. So black holes just have normal gravity like everything else, except they're just very, very small for the amount of gravity that they have. So essentially, for example, if you replaced the sun with a black hole of the same amount of mass as the sun, obviously it would be very dark on Earth and very cold and very bad, but nothing would get sucked in. All of the planets would remain in their same orbits. Everything would go the same way it always has. So black holes don't really suck things in. I think, honestly, like the more scarier version of black holes are supermassive black holes, but those are pretty much just at the center of galaxies, and we're very far away from the center of our galaxy.
Yes.
So it's nothing to worry about, really.
Awesome. And I also think something people get scared about with black holes is that they think that they're like impossible to find and that they're just like around everywhere and we would never know. I think people forget, like, we have a picture of them now. Like,
Yeah,
we can detect them.
Yeah, we have pictures of them, and we're very good at figuring out, hey, there's something weird gravitationally happening. What's that?
Yeah.
And I think we'd be able to figure out, if the outer planets all of a sudden started doing something weird in their orbits because of a passing rogue black hole, we would notice, and we'd be like, hey, something's happening.
Right. Yeah, it's not going to sneak up on us
Yeah,
like
yeah,
that.
yeah.
Yeah. I mean, that's how Neptune was discovered, right? Was that we were like, something weird is happening gravitationally that we can't explain. We think there's probably a planet there. We should look for a planet. And then there was.
Yes, actually, I really recently did a planetarium show on the history of like the planets and our like discoveries of them, and it was literally this guy Leverrier. He was doing calculations on the orbit of Uranus, and he noticed that there was some weird anomalies that he couldn't entirely explain, and he said, hey, I think there might be another planet. And he got a incredibly precise prediction, and he told this guy who works at an observatory, I think his name was Gall.
Mm-hmm.
He told Gall, hey, point your telescope at this part of the sky on this night and just look for a planet. And Gall did, and within 1 degree of Leverrier's prediction, there was Neptune.
That's incredible.
Yeah.
Science is awesome.
Yeah, science is insane. It's so cool.
Awesome. Well, thank you for sharing that. I hate to interrupt here, but we're going to have to take a short break and we'll be right back. All right, so welcome back to WFNP 88.7 The Edge, Rosendale. This is continuing with Curiosities of the Cosmos. I'm your host, Allyson Sheneman, and I'm joined today by Stoker, a senior and student of astronomy at SUNY New Paltz. We just had an incredible conversation about science communication, planetarium, supernovae, and black holes, and we're going to continue now with some more on observational astronomy. So could you describe your research on supernovae as if you were explaining it to a 5-year-old?
Absolutely. I would love to. First, let me just briefly mention supernovae for those who don't know. There are a couple different types, but the main type that we think about when we think about supernovae, and the type that I was studying, is called a type 2 supernova, also called a core collapse supernova. So that is the result of a massive star at least 8 to 10 times the mass of our sun dying, and during its death phase, its core collapses, and then a huge amount of energy and light is released in that explosion. So supernovae happen all over the place in the universe, and we were lucky enough that back in May of 2023, May 19th, 2023, there was a Japanese astronomer named Koichi Itagaki, and he noticed in a spiral galaxy in the constellation of Ursa Major, really close to the handle of the Big Dipper, he noticed a new, very bright light in that galaxy, and it was very quickly determined that that was a supernova. It was given a designation, which is a little bit of a mouthful. It was SN 2023 IXF, so SN for supernova, 2023 for the year, and then they just put a few letters after it to distinguish it from all the other ones. Yeah. And so I was just scrolling through my news feed a few days later, and I saw an article about it. And I saw in the article, it said that this supernova is I think it was at that point, a magnitude 11, which the magnitude is basically the brightness of it. And I knew that in our observatory at SUNY New Paltz, with our large telescope and with our special camera that we use called a CCD camera, that's something that we would have been able to see. So immediately I was like, I gotta go out there. I gotta go see if I can see this. Yeah. And one of my favorite things that our professor, Dr. Bartholomew, says is that science is a collaborative effort. So obviously I didn't want to go alone. So I knew that this was just after the spring semester had ended. But I knew from the planetarium that one of our other classmates, his name's Dylan Zerba, he was also going to be around during the summer. So I was like, hey, Dylan, I want to go try to look at this supernova, try to take pictures of it. Do you want to come? And he was like, absolutely. So me and Dylan, we went to the observatory at SUNY New Paltz. We started taking pictures of the galaxy. The galaxy that it's in is called the Pinwheel Galaxy. Though, honestly, a lot of galaxies have names super similar to that, like the Whirlpool Galaxy. Yeah. There's the Southern Pinwheel Galaxy. There's the Cartwheel Galaxy. So I usually just call it by its designation, which is M101, because it's a lot easier to remember. 101 is a nice number.
I was going to say, it kind of sounds cooler.
Yeah, it does. So we were taking pictures of the M101 galaxy, and we pulled up the article about the supernova, and we were looking at all of the pictures that other people had taken of the supernova, and we were comparing those pictures to our picture, and we were trying to figure out, all right, which dot in this galaxy is the supernova? And finally, we found it. We were like, oh my God, it's this little dot right here. And it was one of the brightest things in the galaxy, which is just a fascinating feature of supernovae that usually they get so bright they outshine their host galaxy, which is absolutely wild. But the absolute joy that me and Dylan felt when we realized, oh my God, we got this. We're looking at this right now. Yeah. Because supernovae, they are very common in the universe, as I've said before, but close ones are a little bit less common. So this one, I believe the news article I was reading called it the closest supernova in the last 5 years to us. And by close, I mean it is 21 million light years away.
Yeah. Which is plenty far.
Yeah. But in terms of astronomy, that's not that far.
Yeah.
Yeah, practically in our backyard. So, but after that first night, we were talking to Dr. Bartholomew, who is our advisor for the project, and she said, hey, if you guys want to keep taking pictures of this supernova, I will give you research credit. And we were like, yeah, we loved taking the first picture. We're going to keep doing this. So basically we ended up over the course of about 6 months, every night that it was clear and everything was working at the observatory, we would go out and we would take pictures of this supernova. And eventually we had, over 100 images of M101 with the cute little supernova right in it. And we took the data from the images. So because we use a special camera called a CCD, we can actually quantifiably measure the brightness of objects in our images. So we measured the brightness of supernova 2023 IXF over the course of 6 months, and we made basically a graph of how its light changes over time. And because there are a ton of different supernova types, I briefly mentioned like type 2 supernova, but there's smaller classifications of that. There's type 2P, there's type 2L, there's a whole bunch. Ours happens to be a type 2P, but actually, no, sorry. It's a type 2L. Sorry, misspoke there. But basically, the shape of the light curve will tell you what kind of supernova it is. And it also tells you a few interesting things about basically the light that's coming out of it and some kind of the features of the supernova. So it was super duper cool to do that. We spent way more time at the observatory than I even thought was possible. And because we spent so much time at the observatory, we ended up like refining our techniques of taking images. We got to be pretty much experts at like doing all of this stuff, which eventually led to both Dylan and I are now learning assistants for the observational astronomy class that's happening this semester, because we're basically
Experts?
we're basically experts in the field of using the observatory, to the point where even like some of the techniques that we ended up using by the end are stuff that Dr. Bartholomew, who runs the observational astronomy class, doesn't even really use herself. But I'm like, this is so much easier, Dr. B.
So awesome.
Yeah.
So just for our listeners to clarify too, because we've thrown around the term light year a handful of times now, could you elaborate on what a light year is for somebody who might not know?
Yes, of course. So a light year is a distance, not a time. It's a common misconception. It is the amount, basically it's the distance that light will travel at the speed of light in a year.
Yes.
So, yeah.
Which is very far.
It's very, very far. Off the top of my head, I don't remember how many miles or kilometers it is.
Very many.
But it's a lot. It's quite a lot.
Yeah, I always like to contextualize it because I can never remember. It's a huge number, and I don't know, somebody famous and important once said, like, don't memorize anything you can just look up. Like,
yeah.
I'm not going to memorize that.
Yeah.
Maybe as I grow into the field, it'll be something that I use so much it becomes second nature, but it's not worth it. It's a big number and you can Google it. But the way that I always contextualize it is thinking about how long it takes light to travel from like the moon to the earth, reflecting obviously sunlight from the moon onto the earth and from the sun to the earth. And I want to say it's like 8 minutes or so for sunlight to get to the earth.
From the sun to the earth it is 8 minutes. It takes 8 minutes for the light to get to us. And another thing that slightly helps me contextualize it, but you do need to know a little bit about the stars, is that the closest stars to us are about 4 light years away.
Crazy.
Yeah,
which means that the light from them takes 4 years to get to us, as the light from the sun takes 8 minutes, to get to us from the sun.
Yeah.
So thinking about like how far we are from the sun being like 8 minutes away, and how big of a scale that really is, and then trying to put that on a scale where instead of 8 minutes, it's 4 years of it traveling the same speed, and that's the next closest thing to us. It feels like, I don't know. Very perspective setting, a little isolating.
Yeah, literally. I mean, so the supernova I'm studying, 21 million light years away. That means that supernova actually happened 21 million years ago, and we're just seeing the light from it now. So that's absolutely insane.
It makes me feel so much luckier when things like that happen, where it's like, it happened 21 million years ago, and it could have shown up in my lifetime or just barely missed me. But I'm just lucky enough that I fall within the like 80 years or so that I might live falls within the time that it happens to make it here. Like that's awesome.
That's also one of the things about my research that I'm so grateful for, and I am so happy about, is that it was really like right place, right time research.
Yeah.
I was here over the summer. Dylan was here over the summer. We both had already learned how to use the observatory. We both had the resources we needed. Our advisor was super excited to let us just go wild and do this, and it was incredible. Like, you know, it's really a lot of like transient, which means like, you know, like things that happen very briefly, like astronomical phenomenons. It's so easy to just miss them.
Yeah. And because all you have to do is just barely miss.
Yeah, because like I mean, we were talking about how like astronomical timescales are so like often really, really, really massive in comparison to human things, but there are a few like phenomena that are actually really short, and supernovae are one of them. So I believe the SN 2023 IXF, its peak brightness was actually only a few days after discovery.
Wow.
Yeah.
Yeah. So it's really human timescales.
Yeah, and we probably could have, if we had more powerful telescope, we could have actually studied it for longer than 6 months, but we kind of decided after we hit like late November, we kind of let it kind of stop because it was starting to get so dim that it was hard for us to really be able to measure it accurately. And also because of the nature of how the sky moves at that point, it was setting really, really quickly after sunset, so we couldn't get a lot of images of it in. Luckily, because it's in Ursa Major, which is a more northern constellation, which means it spends actually a lot of time above the horizon. It spends, I think, like almost 20 hours a day above the horizon.
Sounds
here
about right.
at this latitude in New Paltz. So at one point I did actually end up going out at I think like 2 a.m. I was out at the observatory taking images of it because it set too fast after sunset for me to get the images. So I just went back when it came back up high enough in the sky. But it was 2 a.m. in late November, so it was freezing.
It takes a lot of commitment.
Yeah, but I mean, it's so... I'm like so passionate about this.
It's worth it.
Yeah, it was really worth it to me, and I'm so excited because I've gotten to share this research with a lot of people, and I feel like it's one of those things where I think I mentioned this to you earlier, that it's one of the things where I can explain it in really simple terms to people who aren't really astronomy oriented, or if I want to talk to like my peers, or if I want to talk to professors, I can also go into the complexities of it.
Yeah.
And so it's kind of something that I feel like was a really great first research project for me, because it means I can communicate it to a lot of different people at a lot of different levels.
Yeah. I think it also takes a really, great and thorough understanding of your research to be able to do that, because while it's definitely harder for certain topics than it is for others to be able to give them that kind of breadth, I think that the more that you are really thoroughly understanding what you're doing, and the more that I guess especially in something like this where you're really collecting data, that the more that you understand the mechanisms of how that works, what the information that you're getting is actually telling you, it also becomes easier then to be able to teach it to that kind of broader group of people.
Yeah, absolutely. Though that's not to say that I completely understand everything. I do know, or in January, I went to the Conference of Undergraduate Women and Gender Minorities in Physics, and I presented a poster about this research. And unfortunately, somehow, most of the people who came to my poster narrowed in on the exact thing that is hardest for me to explain, which is because supernovae are so hard to study because they're so transient. There are some mechanisms we don't entirely understand. So in my light curve, there's certain features of the light curve that correspond to certain like physical things that are happening, but it's very complicated and hard for me to describe, and almost
Right.
every single person was like, why is it doing that? And I was like, oh, okay,
They
I'll do
have
my
a way of
best.
finding the thing you don't.
Yeah. I was like, I'll do my best to explain this. It may not be entirely right, but this
Yeah.
is my best understanding. And they were
Right.
all, of course, very like
Understand.
understanding of that. And luckily, none of them were supernovae experts.
Yeah.
So
Comes in handy.
Yeah.
For sure. Awesome. So we actually have another segment that we're going to cut to now. So this segment is our Curiosity Corner. So this is where I get to tell you some fun facts, and you get to rate how mind-blowing they are on a scale of 0 to 10. So 0 is it's not very fun, you already knew it, and 10 is like, I'm going to think about this every day for the rest of my life, good or bad.
all right.
So I have hand-selected these for you. I think you're going to like them.
Okay.
You feeling ready?
Yes.
Okay.
Very ready.
So this first one is kind of a curveball, but I promise the other two get more like things specifically that I think you're interested in.
All
This
right.
first one is just kind of like, I don't know, it's interesting, it's kind of weird.
Okay.
Yeah. It feels wrong to say right after being like, I hand selected these for you, and then I'm going to tell you a fun fact about chickens. So I'm like,
No, I love chickens.
okay. There are at least 3 chickens for every 1 person in the world. Estimates show there are about 25 billion chickens in the world and just around 8 billion people.
I love that. Yeah. And I think, no, that makes a lot of sense to me, actually. You know, like, it's a huge industry.
Yeah.
And while chickens are super cute and fun and clucky, I do also like to eat them. I love me some chicken nuggets. That is a very good fact.
Yeah.
I do like that a lot. I think I'm going to give it a 7.
A 7. That feels
Yeah.
good. That's like a passing grade.
Yeah, yeah. You know,
Yeah.
that's like
totally.
a C. C's get degrees.
C's get degrees. Awesome. Yeah. 3 chickens for every 1 person. That one, like, I read that and I was like, that is going to sit with me for a second.
Yeah, no, one of my best friends, she has chickens,
Yeah.
and so I'm just immediately thinking about her, and I'm like, yeah, she has like 5 chickens, and there's only 2 people who live at her house, so makes sense.
Yeah. I mean, I'm sure most of them are probably in like not great living situations.
Well, my friend keeps
but-
very good care of her chickens, just so you know.
Yeah. And thank God for that, right?
Yeah.
All right. So this one requires some context. So you're going to have to bear with me.
Okay.
Or should I say, water bear with me.
Oh? Ooh, okay.
So we're talking about tardigrades.
Yeah.
So for people who don't know, phyla are a taxonomic ranking. It's right below kingdom. So it's like a biology thing there. So like a phyla could be like vertebrates, which are like all animals with spines or backbones, and arthropods, which are like all insects, and arachnids, and also crustaceans. So they tend to be pretty like large taxonomic groups, just as like background context. So tardigrades, which are also known as water bears, are microscopic, the first animals known to survive direct exposure to space. They've survived 5 different mass extinctions, and they comprise their own entire phylum.
I absolutely love that. I think I knew a little bit about that before, but it's so insane to me.
Yeah.
I mean,
Unreal.
we go out to space, we die instantly. You're done.
Yeah.
The water bear, nah. They chillin'.
Yeah.
They're just chilling
It's
out there.
awesome.
I absolutely love them. And even though I knew a little bit about that, I think I'm still going to give that fun fact an 8.
Awesome. A step above chickens.
Yeah, step above chickens.
Yeah, I'm so fascinated by things like the tardigrades because they're just like, I haven't done any research on them. I've never like seen them in classes or anything. It's not something that we like super cover. But it's just one of those things that like I think similar to you probably I just kind of always known a little bit about. And the idea that like they can get so big that you can like almost see them. They're like right on the edge of what our like eyes can make out. And yet they can also be super, super tiny where you could only see them with a microscope, and they can go to space and just be fine and come back and be regular. Like these like extremophilic animals are just so fascinating to me. Extremophilic being can survive in extreme environments.
You think that tardigrades could survive on Mars?
That's what I'm saying, right? And so maybe it's just the like astrobiology in me that's like, this is what we're looking for when we're looking for animals that, or I shouldn't say animals, when we're looking for living organisms elsewhere in the solar system and beyond. I mean, is that not kind of exactly what we're looking for? We're looking for extreme environment surviving beings, right?
Yeah.
And so if they can survive direct exposure to space, they can probably survive a like lower atmosphere like the one that Mars has, or like is not as dense, not as material rich.
Yeah. Obviously I don't know enough about them, but can I counter your fun fact with something that I saw? I can't verify this, so I know it's a little bit of a faux pas, but I'm pretty sure I saw something about potentially fungi growing outside the International Space Station.
I believe I have seen this as well. I think because tardigrades are the first animal that we know of, like they were the first ones where we're like, oh my god, things can actually survive in space. And since then there have been other things that we know can survive in space. And I don't know if it was the ISS specifically. I'm not as sure of that, but I know there are types of fungi that can survive in space, which is like also crazy.
Fungi are just absolutely bonkers.
Yeah.
Wild.
They're awesome.
They're so cool. And I think, aren't they like closer to animals than they are to plants?
They sure are. Yeah, and that's something that like in thinking about taxonomic ranking that is so fascinating to me. I've recently taken plant morphology, which was such an incredible class. I did not realize that I liked plants as much as I do, and then I took that class and it was awesome. And I'm now in plant ecophysiology, which is ecology and also physiology. And in doing that, we cover a lot in both of those classes about taxonomic rankings. And so I've kind of memorized a lot of these like phyla and the kingdoms and all of these like subclasses and stuff like that to be able to differentiate plants and identify them just like out in the field. But I've learned the most about taxonomic rankings through my molecular biology class, because we used to just kind of look at a thing and be like, those two things look similar, they're the same. And now we obviously have a lot more detail than that, and a lot of that detail comes from looking at the DNA and the like genetic sequences. And so now we've been able to discover that things that we thought were really closely related aren't, and things that aren't are. And so there used to be things, including in the phylum for tardigrades, that are actually now in the phylum for worms, because we just had no idea that even though they look alike, they're not that closely related at all. So it's the same with fungi. They're closer to us than they are to plants, which feels wrong.
Wild.
But it's awesome. They're so cool.
Yeah.
Yeah. I need more fun facts about fungi on here.
They are fun guy facts.
See, I knew you'd like the water bear with me, and I was like, when I wrote that one down, I was like, this is the perfect episode.
I feel like it's so weird because in high school it was totally different, but I do feel like in our astronomy classes I end up being a little bit of like the class clown. But just because our professor, Dr. Bartholomew, absolutely encourages it.
Yeah.
She loves my jokes. Even if she's rolling her eyes, she loves them.
Yeah. We do a lot of dad jokes and puns, and yeah, it's worth it. It's a good time.
Yeah.
All right, last one. This one you might already know, so I was a little worried, but it's one of my favorites, and it had to go on the show at some point, and I was like, this is a good time for it. There are likely more trees on Earth than there are stars in the Milky Way galaxy. So there are estimated to be a few 100 billion stars in the Milky Way, and there are likely trillions of trees on Earth.
Yeah, actually, I think I saw this recently, and I kind of had like an inkling. It's absolutely just like numbers.
Yeah.
It's so hard for like humans to wrap their minds around numbers and how many things there are in like a group. And it's absolutely wild to me.
Yeah.
And I'm going to hijack your fun fact a little bit.
Go for it.
So the Milky Way, we think it has probably between 100 and 300 billion stars estimated.
Yep.
Our closest major galactic neighbor is the Andromeda Galaxy, We believe the Andromeda Galaxy has about 1 trillion stars in it, with a T, a trillion stars. So I think what I heard was about 3 trillion trees on Earth.
Yeah.
So
those are all the same numbers I got, so probably right.
So trees on Earth still beating the Andromeda Galaxy.
Awesome.
However, my dear friend, the galaxy M101 that I was studying, take a guess. Tell me, how many stars do you think?
I was
are
not
in
expecting this
M101?
fun fact to go here, but I'm so excited to know. I'm assuming because you brought it up, it has to be more than 3 trillion. No?
Not quite.
Okay.
However,
The trees still win.
the trees are still winning, but I do briefly want to talk about M101
Yeah, go
because
for
it is an absolutely insane galaxy. Like, setting aside my favorite little supernova guy, me and Dylan call it our guy because that's our guy.
It's our guy.
Yeah, that's our guy. So M101 is a spiral galaxy, and it's also a spiral galaxy that we sometimes call grand design because it has really well-defined spiral arms. It's so beautiful. I'm sure you've seen pictures of my... I've shown you pictures of M101.
Absolutely.
For sure. It's also the central... It's in a group of galaxies. So, like, there's the local group of galaxies with the Milky Way and the Andromeda Galaxy, and the Triangulum Galaxy and a few small galaxies. M101 is in a galaxy group. You'll never guess the name of it. It is the M101 group.
We're very creative with our naming as astronomers.
But it is the central galaxy in its group, and there's 6 other galaxies that are pretty much all satellites of it.
Gotcha.
So they're pulling on it a lot, and it has a lot of, like, because of the gravitational interactions, it has these really pretty little tidal tails on it, and it is the center of the group, and it gets its name because M101 has... about 1 trillion stars, just like the Andromeda Galaxy.
That's awesome.
And it's so big.
Yeah.
We also see, we don't see a ton of supernovae in the Andromeda Galaxy, which makes us think maybe it has a lower rate of star formation. However, M101 has had a fair amount of observed supernovae.
Interesting.
Yeah. Sorry, I kind of hijacked your thing, but the trees are really really cool. But if we took the Milky Way, Andromeda, M101, and maybe Triangulum, I think we could beat out the trees.
Yeah.
So
I think that means the trees still win.
The trees do still win, but I'm proposing we have an Avengers style team of galaxies to beat the trees.
I think I see where you're going, but to me it feels that much more impressive that it would take an Avengers style team of galaxies to beat trees.
Yeah.
And they're trees.
Yeah.
Not that trees aren't impressive.
No, I love trees.
So impressive.
Adore trees. Yeah.
That's so awesome. I have so many questions about that for you, but I'm going to save them till after the show because we are a little over time to our next break. So we're going to cut again to a little short break. Stay tuned. We'll be right back with more fun conversations and galaxies. All right, so welcome back to WFMP 88.7 The Edge, Rosendale. This is continuing with Curiosities of the Cosmos. I'm your host, Allyson Sheneman, and I am joined today by Stoker, a senior and student of astronomy at SUNY New Paltz. For our last few minutes and to end every episode, I ask the guests to bring in their favorite question that they've ever been asked. So, Stoker, what is your favorite question?
There's a lot of really good ones I've gotten. Some of them are more science-y. Some of them weren't entirely questions, but I do want to say honorable mention.
Okay.
One time I was doing a planetarium show for, I think, first graders, and as they were walking out, one of the kids said, "This was the best day of my life."
Oh.
I nearly cried at that. But it wasn't a question, so I will give you, I think, my best question, which I believe it was after a planetarium show for, I think, either second or third graders. It was, "How do you know so much?"
That's so flattering.
Yeah.
That's so sweet.
Which was, I mean, just on a lot of levels, I loved that question so much because, first of all, I'm sure you know, imposter syndrome, especially for women and gender minorities in science fields, it's a lot. I mean, I'm like, you know, but being able to see somebody who thinks I'm an authority and I'm really smart is like, wow, really touching. But also, it really shows that that child had a curiosity. They wanted to know, how can I know all of these things? And I felt like it was a really great moment because I got to tell them basically how I got to where I am today. So, you know, I essentially told them I studied a lot. And I found really good places that had good programs like the planetarium to memorize all those constellations. I spent a lot of extra hours in the planetarium when we took the planetarium operations class that we took together. I would go out on clear nights so that I could connect the constellations that I'd learned in the planetarium to the constellations in the night sky. And then, of course, all my astronomy classes and all of the documentaries I've watched about astronomy. And it's so, there's a lot to learn, but if you have a passion for it, it just like builds on itself. One thing is like, the more new stuff I learn in astronomy, the more that I want to learn more, you know? Like, it just keeps like snowballing. The more I want to do, the more I want to learn, the more I want to share what I know with people. So just getting that question, like, how do you know so much? It felt really good to me, you know? And I feel like I was able to share kind of my path with people, and I was able to tell them, hey, if you want to be like me, if you want to do something like this, here's some steps you can take. Because astronomy, I feel like there is a kind of a barrier to entry to it. There's a lot of stuff you can learn as just like an amateur. Like, there's so many great documentaries, there's so many great YouTube channels. There's a lot of places where you can learn like kind of other stuff, but it can be hard for like the more academic side of things. I know I'm honestly not much of an academic person. That's part of why I know like you and a lot of our other classmates, you're all getting into grad school, you're applying to grad school. I'm not much of a school person. If I go to grad school, I gotta take a break first because I'm not, you know, that...
It's a lot.
It is a lot. But I feel like just with the knowledge that I have right now, I think I've already seen people, for example, this kid asking me this question who already thinks that, like, I'm good enough to be teaching people about some of this stuff.
That is so sweet. Yeah, I feel like especially... now, like, entering into like that senior year of undergrad, that I really start to notice that I have learned a lot. And I think sometimes it's hard to see because it's little things that just build on each other every day. But being able to look back and be like, oh, when I got here, I didn't know anything about this stuff. And to be able to go to conferences and present my research and have people ask me questions that I know the answers to, and to turn around and be able to give a show for first graders, right? And then to meet with people on kind of both ends of this, like, really young and really curious, but like doesn't know a lot yet, to like these experts in the field who, like, you get to be a part of, like, reigniting that, like, curiosity and stuff. Like, I feel like it's hard to realize in the day-to-day just how much has changed and how much you've grown and how much you've learned. And having those moments is so, like, precious and important to be able to look back and be like, I did that. Like, I've learned something. This was worth my time and my energy and the effort that it takes, because it's hard. I mean, even, like, I love school. I love learning. I think that school and education needs a lot of reform. And that's why, like, my first episode of the show was about education, because I wanted that to be, like, an immediate conversation here. Because even though I love school, it's not for everyone, and it should be. And I feel like, for me at least, in really loving school, I've also found that, like, the more that I do it, the more I, like, burn out. and the harder it gets, and you just kind of are like at a point you're like trudging and you're like, wait a second, like I'm supposed to love doing this, like
Yeah.
like to find that like spark again. And I feel like it's things like that, those moments where it's like, oh, I have learned something, like
Yeah.
it's all worth it, like
Yeah.
this is good. I'm doing the
Yeah.
right thing, I'm on the right track. And it should be normal to take breaks and to come back and to take things slower, go faster, do things at whatever pace is right for you. There should be no like cookie cutter student, cookie cutter education.
No, absolutely. I will be completely transparent here. I have been in college since 2014.
Yeah.
So I started at community college. I was super part-time because I was also working, because unfortunately we live in a society needed money.
and college is expensive.
Yeah. And then I transferred here, and finally I'm now graduated in August.
Congratulations.
Yeah. But I'll still get to go to commencement with you in May.
Yes.
Yeah, but but there's also a lot of people who I think they really want to learn more about astronomy, but they don't want to go to school, which is why I think like outreach stuff is so important. Places like planetariums, places like science museums, where you can learn this stuff without having to go into a classroom, without having to pay tuition, all of that stuff. It's absolutely like, it's in my mind, one of the best things in the world, that you can just go to a place and you can talk to somebody who knows a lot about the stuff, and you can learn things, and you can do it at any age.
Yeah. And at any pace.
Mm-hmm.
Yeah. Well, that was a wonderful conversation. I'm so glad that you came on the show today. This was like such a like healing conversation for me. And so like, I don't know, it was just so nice to be able to like sit down and like hear about your research, because we haven't really like talked extensively and in depth about the process and everything. It was so cool to like hear about everything that came into making that possible, and to hear more about like your story, what brought you here, what you're interested in doing, and to know like other people who are also interested in the thing that I want to do too. Because I feel like sometimes science communication can get a little looked down upon. So it's wonderful to have a conversation. It was so good to have you on the show today. Sadly, that is all the time that we had. So thank you again, Stoker, for coming on the show.
Thank you for having me.
Of course. And of course, thank you all for listening. This has been your host, Allyson Sheneman, and my guest,
Stoker Stoker,
on Curiosities of the Cosmos.